All right, Chapter 7 deals with a special type of probability distribution called the normal distribution. The normal distribution is a continuous distribution, meaning any value on the curve or fraction of a value is possible. And it's typically denoted by this bell-shaped curve, which has a very high probability of occurrence at the mean, and then gradually lower and lower probabilities of occurrence as you move further away from the mean. This is the bell-shaped curve of the empirical rule that we saw before. Now, this normal distribution has the mean dissects the curve in half. So 50% of the area under the curve lies here. 50% of the area under the curve lies below. So it's a mirror image. Now, finding probabilities for a continuous distribution involves finding the area of the curve that's between two numbers, the mean and usually another value labeled by x. So you're not going to find the value of exactly finding a number, but like what's the probability the value we select a value between 10 and 20 or something like that. Now back in chapter 4 we found that the empirical rule stated that 68% of the curve of all values lie within one standard deviation above and below the mean. Now I promised you that I would tell you where that comes from, and we're going to do that now. Finding the area under a curve is a calculus function, and since we don't have calculus available to us, we're going to use a table that's in the back of your statistics book called the z-table, or the normal distribution table. This table is all based on something known as z-values. And a z-value requires us to translate a number into a z-score. The z-value is simply the number of standard deviations a value is away from the mean. That's what a z-value is, and that's what the table uses. Let's take an example. Let's say I have a distribution that has a mean of 120 and a standard deviation of 10. Now I want to find the probability of getting a value between 120 and 130. Now the number 130 is exactly one standard deviation above the mean. So the z-value here would be equal to 1. Now if you look at the table in the back of the book, the z-table finds the first two digits of z down the left-hand side. So I would find 1.0 here, and the very last digit of z across the top here, and it would give us an area under the curve of 0.3413. Therefore, the area between 120 and 130 is 0.3413, or the probability. Now, where you go one standard deviation below the mean, that would be also 0.3413, and a total of 68%. So that's where the 68% from. What I'd like you to do is pause the video now and see if you can find these z-values in the table in the back of the book. Write down what they are, what the area is in the z-table in the back of the book. All right. What you should have been able to find is 1.47 is 0.4292. 2.56, 0.4948. 0.42 is 0.1628. 3.8 is not in the table. And that's because when you go 3.8 standard deviations above the mean, the value is so small, it's so close to 0.5 that we just say basically it's equal to 0.5.